Right, so Assalamu alaikum everyone. Bismillahirrahmanirrahim. So we'll start off with chapter 3 today, which is the transport layer services. Before we start, I think we just wait a couple of minutes for people to join in. We just have 2 participants. So any questions before we start? Can you hear me? Can you hear me, Ji?
Yes, sir.
Great, Mom. Just open up the chat window. So any questions before we start? So just one announcement, just to remind everyone that this Friday we won't have a class because of Eid Milad al-Nabi, and in lieu of that, we'll have a class on Saturday, same time. So are you having midterm exams this week or next week? Kis tarah ho rahe hain?
Not this, probably next week.
Next week, all right. Okay.
Sir, that's one of the reasons why some of us didn't want a quiz on Sunday.
Didn't want a quiz on Sunday. Okay, so pehle hi mutalaba hai. Chale, theek hai, we'll discuss that.
Thank you, sir.
So अभी तक कैसे जा रहे हैं quizzes? Have you all aced them all or कुछ मुश्किल है? Are there any difficulties, any problems in them?
Sir, otherwise तो ठीक है. It's just that Sunday के दिन के थोड़े से issues हो जाते हैं because most of us have prior commitments on Sundays and especially considering families का फिर वहाँ पे involvement काफी हो जाती है. And then Sundays को especially पहले तो initially तो था ना कि we had this whole window कि whenever we're free on Sunday we can access the quiz. अब when we have to access it exactly at a certain time, वो थोड़े से issue कर देता है. But otherwise ठीक जा रहे हैं quizzes.
Okay. Chale, we'll take a look at the window. I mean, is a later window, does that work better, or an earlier window? Let's say Sunday subah when everyone, the family is asleep, subah test de ke farag ho jaye, would that work? Yeah, nahi. Subah is too early.
So I guess because everyone over here has their own opinions on this, so I don't think we'll be able to come to a conclusion. Exactly. There won't be any consensus in this case. So I would suggest get like a 12-hour window where anyone can, fit in their times.
12 hours, huh? That's a big window. Oh. वो तो 6 घंटे का टेस्ट हो तो 12-hour window makes sense, but चले anyway, we'll take it.
टेस्ट भी आ जाता है ना अब तो इतने बड़े हो गए कि चीटिंग का किसी को शौक भी नहीं है.
हाँ, ठीक है, I understand.
Thank you, sir.
Okay, so let's start. Transport layer services are what we'll be talking about today. इसके अंदर, if you remember, the transport layer is the first end-to-end layer. ठीक है? So you have end systems, and on your end systems or hosts, you will have a certain application layer process running. And we saw examples of application layer processes. They could be a web browser and a web server. You could have, let's say, an email client and an email server. You could have, let's say, a DNS client and DNS server to me, basically. So a DNS server. Isi tarah se you could have other application layer processes running at your end systems. Okay? So in between, they're interconnected through networks. And networks where you've got links and you've got basically routers, which are going to be forwarding your packets hop by hop to the destination. And you could have different technologies at each one of these networks. So you could have a fiber optic link somewhere, you could have a satellite link somewhere, you could have other protocols and other technologies in between. So basically, the internet, glues these different types of networks together. And we've looked at the different issues that you're going to have over there. And we've talked about the broad issues of having addresses and forwarding packets hop by hop. So basically, the network layer is responsible for forwarding packets hop by hop until those packets reach their end systems. Once they get to the end systems, so they have to be then multiplexed to the appropriate application layer process. Okay? So it's just like this that the analogy which will explain things much better. But we did have an analogy earlier, which was that you had, let's say, between two companies, the CEOs talking to each other, and you had secretaries who were managing that communication. And then you had the FedEx system, which was forwarding the actual packets that were being sent through mail. So the mailing system is analogous to the network layer. The secretaries are analogous to the transport layer, which are the first end-to-end layer. And then you've got the CEOs who are communicating. Those are the application layer processes. So any questions so far? Transport layer, is that exactly clear? What is the transport layer? And transport layer ne exactly kya karna hai? Any questions here? Okay. So transport layer mein, basically what you're setting up is a logical end-to-end transport service between the end systems. So you've got end systems, which are the hosts, computers, they could be smartphones, it could be any other devices that you have at the edge of the internet. And yahan pe you have application processes running on these different hosts. Now, on each host, you could have multiple application processes. And the transport layer is basically responsible for breaking up the messages of these different application layer processes into what we call segments. So different layers के ऊपर जो आपके पास protocol data unit है, we use different names. For the transport layer, protocol data units or PDUs, इनको we call them segments, and we'll call the network layer sort of units as datagrams. ठीक है, and इसी तरह से नीचे जो है आपके पास link layer है. At the data link layer, we'll call the units as frames. So segments, datagrams, and frames are the names that we're going to be using. Now, when you say logical, uska matlab ye hai ke, so as far as the application processes are concerned, for them, it's just like you have a direct connection with the other application layer process. Okay? And ये बीच में आपके पास different जितने भी networks आ रहे हैं, different technologies आ रही हैं, hop by hop आपके different datagrams forward हो रहे हैं वहाँ पे. As far as the end system application layer processes are concerned, for them you have a direct connection. That's why we're calling this a logical end-to-end transport service that is being provided between the application layer processes. Now on the internet, we have two main protocols that are available for the applications. One is called TCP and the other one is UDP. TCP stands for? Anybody? TCP, what does TCP stand for? Anybody? TCP is the transmission control protocol. And UDP, anybody for UDP?
The user datagram protocol.
Very good. The user datagram protocol. Okay, so we'll discuss TCP and UDP mein kya fark hai, and why do we have just two, and what kind of service do they provide to your end systems. Okay. Now, there's an interesting analogy, and wo ye hai ke aapke paas, let's say you've got two houses. Ek, let's say ghar Karachi mein hai aur ek ghar jo hai Lahore mein hai, and you've got 12 kids in one and their cousins. 12 of them live in Lahore. Okay? So the example in the book, they talk of East and West Coast. We'll talk of Karachi and Lahore. And yahan pe you've got two of the children there are responsible for actually collecting the letters from their brothers and sisters and delivering them to TCS or whatever mail system that you're using. Okay? So you can think of the hosts, the end systems, as the houses. And within each house, आपके पास 12 बच्चे हैं. So the processes are the children inside each of the houses. Now the message is, let's say every week, each child writes a letter to 12 other children, 12 of his cousins. So let's say Lahore के अंदर आपके पास 12 बच्चे रहते हैं घर के अंदर. वो हर बच्चा जो है अपने 12 cousins को कराची में एक खत डालता है. So every week you've got 144 letters being sent across from Lahore to Karachi and from Karachi to Lahore. ठीक है? तो घर तक letters पहुंच जाएंगे. But how do we identify कि ये letter किसके लिए destined है? Of course, along with the address of the house, which is equivalent to the IP address, आपने कोई और identifier रखना है जो कि ये identify कर सके कि ये जो particular खत है ये किस बच्चे को जाना है. ठीक है? So the application messages are letters in envelopes, and what you require is some bigger brother or some elder sister or some parent who's going to demultiplex the letters and deliver them to the right child, to the right sibling. ठीक है? तो letters घर तक पहुंच गए. अब घर के अंदर जब तक उस envelope के ऊपर उस बच्चे का नाम नहीं लिखा हुआ है या उसका कमरा नंबर नहीं लिखा हुआ है, तो you cannot actually deliver that letter to the exact child within the house. ठीक है? So the transport layer provides a logical communication between processes, between the end systems के ऊपर एक चीज, between the actual application processes which are running on the end systems. So it's a communication between the different children. ठीक है? So to get to the correct child, you not only need the address of the house, which is the IP address, you also need a further identifier ताकि उस बच्चे तक जो है exact आपका envelope deliver किया जा सके. The network layer protocol is the TCS service or the FedEx service which delivers the letter to the house. But at the house, somebody, one elder brother or sister or the parent needs to then forward that letter to the exact child. And this is called demultiplexing. So multiplexing के time पे, the elder brother has to then collect all the letters and send them through TCS or FedEx to the other city. So that process of collecting all the letters, putting them in envelopes, writing the name of the child and the house address, street address of the end system जहाँ पे deliver होगा, that is analogous to multiplexing, right? So this is a very good analogy in terms of exactly transport layer क्या कर रही. So remember, transport layer works end to end. It only exists on the end hosts. So दरमियान में FedEx के अंदर there is no transport layer. FedEx के अंदर forwarding of datagrams के लिए all you need is the network layer, and उसके नीचे आपके पास of course link layer होगी जो कि technology dependent होगी. Any questions so far? जी, Suhaib, Aisha, Rulan, Shehzad. So anything unclear, please stop me if you have any questions. Ji. Now, you can have two types of services on the internet. The first one is a reliable in-order delivery of these datagrams or the letters. So suppose a single child writes multiple letters. Okay? Now, in order to get an in-order delivery, आपको क्या चाहिए होगा? Ji, any thoughts? How would you ensure in-order delivery? So I have a letter number 1, a letter number 2, a letter number 3. They're delivered to the postal system. There is no guarantee that I would have some identifier to identify the numbers. Thank you, Asim. So Asim tells us that we would require an identifier to number those letters. to number the datagrams, and that's correct. So unless you number the datagrams or the segments, I should say, it's not going to be possible to identify कि ये कौन सा segment number है. So if I number them, when I receive them, I can then reorder them. So in order delivery के लिए, the requirement is numbering the segments. Then we've got two other words over here, TCP के लिए, congestion control and flow control. We'll talk about them in a bit later. And then the third one is a connection setup. इसके बारे में भी थोड़ा सा बताएंगे. The other service that you have is UDP. That is a no-frills extension of best effort IP. Now, can anybody tell us what do we mean by best effort? When we say best effort IP, best effort का क्या मतलब है? What is best effort? Ji, anybody?
Best effort to deliver the packet, but not guaranteed.
That's very good. So best effort means कि आप पूरी कोशिश करेंगे, but no guarantees. In other words, best effort is another term for unreliable. ठीक है? So best effort is basically equal to unreliable. ठीक है? जैसे हम कहते हैं जी हम कोशिश करेंगे, इंशाल्लाह ये हो जाएगा. ठीक है? There are no guarantees कि ये होगा नहीं होगा. ठीक है? So that is what TCP के नीचे जो service है IP की, that is what IP provides. So notice on the internet when you're forwarding these packets, packet by packet, अगर एक packet पहुंचता है किसी router को, and that router has its buffer filled up, and there's a possibility that that packet gets dropped over there. It's possible that the packet gets corrupted over there. Okay? So there are no guarantees in the internet that the packet will get delivered properly. Okay? It could get corrupted, it could get lost on the way. So if packets, individual packets, जो के नीचे mail service है आपके पास, TCS है या FedEx है, whatever, उसमें guarantees अगर नहीं है, तो then how are you going to have a service at the end-to-end or at the transport layer, which is going to give you guarantees that you have a reliable delivery of information? वो कैसे होगा? ठीक है? Think about this. हाँ जी. Any thoughts? Any thoughts? So एक तो we said कि you'll have to number those frames. Secondly, you'll have to have some mechanism at the end system, at the transport layer, which is going to keep track कि कौन सा segment मिल गया है and कौन सा missing है. Notice ये end systems भी होगा. And जो missing है, it will request for maybe a retransmission. ठीक है? So if you number them and keep track कि कौन से आ गए and कौन से pending है, and then जो missing है, उनको आप, you somehow send a message back that please retransmit this particular one. I didn't get it through. So you need to have some mechanism of numbering them, acknowledging कि ये मिल गया या नहीं मिला, and अगर नहीं मिला, so then retransmit that. Only then can you make sure कि जो ऊपर आपके पास application layer process है, उसको you are providing reliable delivery. ठीक है? So दो किस्म की services available आपके पास. एक TCP है which provides that reliable delivery. So notice कि providing that reliable delivery to the processes will require this end system to do something extra. And that something extra is numbering all the segments, keeping track of कौन से पहुंच गए, कौन से नहीं पहुंचे, and जो नहीं पहुंचे उनके लिए having some mechanism of retransmitting those. ठीक है? इसके अलावा you've got congestion control and flow control, and we'll talk about these. Basically, these are rate control mechanisms, pacing mechanisms. Okay, let's say packets या segments भेज रहे on the network. Now, if you're transmitting too many segments, okay, and the network conditions are such that there is congestion, which means that data rates आपके पास इतने possible नहीं है. बहुत सारे लोग बहुत सारा data भेज रहे हैं network के ऊपर, and your capacity of the network is limited. It's not able to handle all of that traffic, just like you have congested roads. Okay? So if you have congested roads, then if you were to limit the number of cars that you allow on the network at that particular time, so then congestion behtar ho jati hai, traffic conditions become better, and the sort of the end-to-end delay of packets reduces. Okay? So congestion control is a mechanism to slow down the rate or to control the rate depending upon the network conditions. Now, sometimes the network may be perfectly fine, but the end system itself may not be able to handle the data rate at which the source is transmitting at. So you might have, let's say, asymmetric kind of capacities available at the rates at which the end systems can deliver things. बिल्कुल एक top of the line, a high-end system hai, which can pump in data at a very high rate into a very high capacity link. दूसरे end पे आपके पास एक बिल्कुल ही low capacity का sort of link available है, and जो end system है वो बड़ा पुराना सा end system है, it's not able to handle that data rate at all. So if the end system is not able to handle the data rate which the source can transmit at, then you'd want to have some kind of a mechanism to slow down. Notice के network पे congestion नहीं है. Network can carry that traffic through. It's just the end system which cannot handle that data rate. So then if the source has to slow down or throttle, that is called flow control. So congestion control is you're slowing down because network में traffic conditions ऐसे हैं कि congestion है. Flow control में you're slowing down because the end system cannot handle the rate at which the source is transmitting at. Okay? So TCP provides for reliable delivery, flow, as well as congestion control. And you also have something else which is called a connection setup. Now remember that the transport layer exists end to end. So what do we mean by connection setup? Okay? So connection simply is going to be some state that you're maintaining, which is keeping track. Let's say before communication takes place, you have some kind of exchange of information, like a handshake. आप कहते हैं मैं data भेजना चाहता हूँ, अगला कहते हैं हाँ जी आप data भेजें. It acknowledges you कि you go ahead and send data, and then you actually transmit data. So before data exchange takes place, you have some kind of a understanding with the other party that you are going to transmit data. A connection is set up. Just like you saw that when you had web pages, web browser जो है वो एक download करता है a web page from a web server. So first of all, a TCP connection is established. So while it's establishing a connection, all the end systems are maintaining some state, okay, that this particular connection is going to be set up. The other side acknowledges कि हाँ जी ठीक है, please go ahead. They have some identifiers, some numbers are set up. कि जो communication होगी, it will start with so and so number and will be acknowledged accordingly. Some setup is done. So notice कि कोई physical तार नहीं बिछाई जाती, कोई और चीज नहीं होती, कोई इस तरह का connection जो है, connection setup simply means that the end systems maintain some state. So you have some kind of a data structure in the end systems which corresponds to that particular connection. ठीक है? Whereas UDP में ऐसा कुछ नहीं है. आपके पास there's a number of times that you require services where you just want a query response. You ask a question, you want a response. जैसे DNS है. DNS में you want to say अच्छा ये जो URL है इसका corresponding IP क्या है. So you send that request to a DNS server. The DNS server responds. अगर उसके पास नहीं है तो response जो है वो negative में आएगा. You then ask that query from another server. ठीक है? So it's a very simple query response. You don't need to set up a connection. You don't need to worry about flow control, congestion control, other things. So उस किस्म की service के लिए you can rely on UDP. ठीक है? So depending on the requirement of the application layer end process, you can either use TCP for reliable delivery, and you can use UDP for a quick kind of a response where it's unreliable, you're not worried about the order, and your segment has that typically contains a complete response. So you don't have multiple segments that are coming through, which have to be numbered, and you have to worry about ordering them, and you have to worry about कि अच्छा कोई चीज miss हो गई तो अब उसको दोबारा transmit करना है. So you're not really worried about that. You just have a simple query response kind of a thing, and उसके लिए IP works best. ठीक है? So let's think about this. Suppose I was to think about the service that we're using, Zoom now. ठीक है? तो आपके ख्याल में would Zoom use TCP or UDP? I mean, Zoom के अंदर देखें, आपके पास एक तो ये है, you've got the chat box. ठीक है? So chat box में जो चीज आप टाइप कर रहे हैं और दूसरी साइड पे लिखी जा रही है, रिसीव हो रही है, रिस्पॉन्स हो रही है, आपके ख्याल में इस किस्म की सर्विस के लिए would you need TCP or UDP? जी. So TCP for chat and UDP for video, that's very good. Acha, UDP for video, why UDP for video? Because in video, basically you have a video stream, usko aap compress kar rahe hain, and then you are transporting that across the internet. And if a packet gets dropped or lost, you don't really have to worry about retransmitting that, because उस particular frame में थोड़ा सा glitch आ जाएगा, but it's not a complete file that end-to-end जानी है. If you have a complete file, for example, an email, or you're doing file transfer, there, of course, if something gets missing, you have to retransmit that. But in live communication, in real-time communication, in streaming communication, ठीक है, अगर कुछ चीज miss हो जाती है, so timeliness is much more important, and you would not wait for retransmitting that again end-to-end and sort of reconstructing that particular frame. You would live with dropping that frame or that voice packet, and थोड़ा सा quality उस particular time के लिए compromise हो जाएगी, garbled हो जाएगी आपकी video या voice, and you would still want timeliness. So therefore, UDP is typically used for live streaming kind of services, whereas TCP is used for reliable transport, जहाँ पे आपने कोई file भेजनी है, जहाँ पे आपने कोई email भेजनी है, जहाँ पे let's say web browsing करनी है. So it's important that whatever you transmit is received in the exact same manner at the recipient, and you're not really worried about the end-to-end delay. Right. So any questions so far? जी. Any questions? Okay, so we talked about multiplexing and demultiplexing, and we said that आपके पास, let's say, ये end systems है, and you have on the end system number 1 over here, you have processes P1 and P2 running, and इस end system पे you have a process P3 running, इस end system पे you have a process P4 running. Now you have the physical link, network, and transport layers, 4 layers, and इसके ऊपर आपके पास application layer में ये process actually run कर रहा है. So now when you transmit, ठीक है, so at the sender end, multiplexing, what that does is it handles data from multiple sockets. So you can think of sockets as basically doors to the application. So the application is going to communicate to the transport layer through a door, through a interface called a socket interface. Okay? And basically, each of these sockets is going to correspond to a process. Okay? And होगा ये कि आपके पास when the same end system is running multiple processes, then of course, when this communication takes place, so at the sending side, you are going to specify that ये जो particular segment है, ये किस process के through जो है जा रही है and कहाँ पे जा रही है, ठीक है? So you have to specify the end system, and then you will also have to specify कि अच्छा इस end system में इसको किस particular process के साथ communicate करना है, ठीक है? So that identifier for the particular process or that particular end system application जिसके साथ आपने communicate करना है is identified through a port number. ठीक है? So if you look at your TCP और UDP segment, ठीक है, तो आपके पास एक source port number होगा और एक destination port number होगा. Port number ये है कि जो particular application communicate कर रही है, जहाँ से data originate हो रहा है, what is the port number of that particular application. And destination port number specifies that on the receiving side, on the end host, आपके पास जो process है, वो किस particular port number के through identified है. ठीक है? Notice that these source port numbers and destination port numbers are 16 bits in length. This means that I can have about 16 different combinations or 65,536 different port numbers. ठीक है? In all. ठीक है जी? Now, typically when we show packets, we show packets like this. आपके पास एक certain length है 32 bit, and then you've got other fields below. Now, what does this mean when we're showing the formats? Notice कि आपके पास header की जो actual length है, suppose I have, let's say, 3 rows of header. So that basically means that my actual packet is 96 bits long. Now, instead of showing one long particular header, जिसमें आप different चीजों को show करते हैं, sort of on paper, to show that concisely, what you do is you specify कि एक row में कितने bits हैं, ठीक है? And then you show, so this is, for example, bit number 0, this is going to be bit number 31. Then you're going to wrap around. Next row के लिए, this is going to be bit number 31, and it's going to go all the way up to bit number 63. Here, next row में you'll have bit number 64, all the way to bit number 95. So अगर आप 0 से numbering कर रहे हैं, so 0 to 95 would be 96 bits in all if you had 3 rows. Similarly, if you had multiple rows, so आप उस तरीके से you show that in compact form by showing multiple rows and something in a row column format. But actually, if you think about it, these bits are part of a big frame, okay? And in the header, they're going to all appear at the head of that particular frame. ठीक है? तो ऐसा नहीं है कि so आपके पास, I mean, the way it works is this is bit number 0 to 31, and then it wraps around. This is bit number 32 on to 63, and so on. You will always see this diagram where the header is shown as multiple rows. In fact, it is one long header, but this is a compact notation for showing the header. So TCP segment में notice कि आपके पास port numbers है, source का and destination का. The IP addresses, they're going to be part of the network header. So that's going to be attached onto this, ठीक है, network. And इसी तरह से आपके पास अगर frame layer है, you'll have the frame layer header attached onto this. इसका जो payload है, that's going to be the actual data that is exchanged between the end processes or the application layer processes. Okay. So any questions here regarding these port numbers? Okay, so basically when you transmit, you're going to specify कि source क्या है और destination क्या है. And इसी तरह when the host receives, it's basically going to look at the destination port number, and based upon the destination port number, it's going to then forward that particular segment to the appropriate application. And that's how you're going to ensure that your segment arrives at the correct process at the end system. Okay. So suppose आप एक application 3 जो है, process 3 is communicating, ठीक है? and you've got these 3 different processes running across 3 different end systems. ठीक है? Now, यहाँ पे आपके पास let's say आपका source port है 9157 and इधर आपके पास जो port है that's 6428 and यहाँ पे आपके पास port है 5775. So when a segment is transmitted from P3 to P1, the source port is 9157 and the destination port is a 6428. Okay? So when this packet arrives over here on this end system, it's your transport layer protocol will read the destination port number as 6428 and will forward this particular segment to this particular process P1 over here, which has this destination port number 6428. अगर इस end system के ऊपर और भी processes चल रहे हैं, so they'll be uniquely identified with a different destination port number. जब वापस आएगा तो of course आपका source port number 6428, destination port number 9157. Similarly, if a packet goes from P1 to P4, your source port number will be 6428. ठीक है? Destination port number is 5775 from P1 to P4, and from P4 to P1, it's going to be source port this, destination port 6428. ठीक है? Any questions here? It's fairly straightforward. Now, TCP may, to identify the connection, you need 4 things. You need a 4 tuple, and that's a source IP, a source port, destination IP, and destination port. Okay. UDP may, you just need 2 things. UDP may, you just need the destination IP and the destination port number, because that is going to forward the segment to the right destination. जब आपके पास दूसरे साइड ने रिस्पॉन्ड करना है तो उसी सेगमेंट में सोर्स पोर्ट नंबर भी एग्जिस्ट करता है in the transport layer header, and in the network layer header you have the IP address of where this particular segment came from. So when you want to send something back, so you're going to use the IP address of the recipient and you're going to use the port number of the recipient to send that particular frame back. लेकिन आपके पास connection नहीं है. So in UDP, you're just sending one segment. It gets to the destination and it has to be multiplexed up to the appropriate process. ठीक है? अगर इसे respond करना है तो it has enough information in the segment header to transmit that particular segment back. ठीक है? But a connection, there is no such thing as a connection in UDP. It's a segment forwarded, segment received. To receive a segment properly, you need simply the destination IP and the destination port number. TCP is connection oriented. Now, connection oriented का मतलब ये है कि end systems में you have to have state which maintains the connection, and that state contains these 4 things, this 4 tuple: the source IP, source port, destination IP, and destination port. ठीक है? And so in a connection oriented situation, आपके पास जो exchange होगा इसमें ये सारी चीजें, source IP and port, source destination IP and port, ये सारी चीजें जो कि UDP segment के अंदर भी मौजूद हैं, ठीक है? They're also present over there, but you will be using all 4 of these things to identify a particular process, because when you set up a connection between P3 and P4, notice that connection is persistent in the sense कि दोनों साइडों पे state maintain हो रही है, and आइंदा जब उस particular communication के सिलसिले में मजीद segments exchange होंगे तो वो segments उन सब में भी ये सारी चीजें मौजूद हैं. When they get to here, of course, you need just the destination port to be able to forward that particular segment to the right process. ठीक है? But इस socket को identify करने के लिए ये चारों चीजें मौजूद हैं. ठीक है? उसकी क्या वजह? उसकी वजह ये है कि for example, I have a server over here and I have clients over here. ये एक web server है. ये let's say Google का server है. ठीक है? एंड मैं इस क्लाइंट से भी गूगल का पेज खोल रहा हूँ और इस क्लाइंट से भी गूगल का पेज खोल रहा हूँ, ठीक है। Now when I open up this page, ठीक है, it's the same page for both, so it'll have the same, ठीक है, it'll have the same destination port number. That is called a well-known port number, ठीक है. So typically web servers will run on an announced, a pre-announced or a well-known port number, let's say port number 80, ठीक है. जिस तरह से mail servers typically run, SMTP servers run on port number 25, FTP runs on port number 21, and so on, so on. IANA ने assign किए हुए well-known port numbers, which are typically port numbers from 10 to 1023. So different application processes के जो well-known port numbers हैं servers के लिए वो predefined है and everyone uses the same numbers. ठीक है. अब होता ये है कि जब आपने connection setup किया तो उसने arrive तो उसी particular destination port पे हुआ. But based upon the source IP and the source port, ठीक है, the destination process is going to create. Now you understand what a process is, right? A process is simply any program in execution. So what happens is that this process instantiates a new thread, ठीक है, which contains this 4 tuple to identify this particular connection. So any subsequent packets coming from this particular client are going to be forwarded to that particular thread or process, sub-process आप कह रहे हैं. Whereas इस particular client से जो connection आ रहे हैं, ठीक है, उसी destination port well-known port number 80 के लिए, it's going to set up a new sub-process for that and assign a different socket to that, and all communication from here to here is going to be handled at that through that particular socket. ठीक है. So to identify a connection-oriented TCP connection, आप ये चारों चीजें source IP and port number, destination IP and port numbers को इस्तेमाल करेंगे to actually identify that particular connection. Okay. Any questions here? Is this clear? जी.
Sir, why are there different processes, application processes on different end systems? Shouldn't there be counterparts like a P3 for a P3 and a P2 for a P2?
It's just how you number them. यानी वो जरूरी नहीं है. Let's say हमने कहा कि अच्छा जी P3 is a web client, ठीक है, and यहाँ भी P3 है, that's another web client, ठीक है, और ये एक email sort of client है, ठीक है. तो यहाँ पे आपके पास let's say एक web server भी चल रहा है और आपके पास क्योंकि वेब सर्वर ने एक कनेक्शन इस क्लाइंट के साथ बनाया हुआ है और एक कनेक्शन उसने जो है इस क्लाइंट के साथ बनाया हुआ है. सो दैट्स अ सेपरेट कनेक्शन. सो दैट सेपरेट कनेक्शन इज आइडेंटिफाइड थ्रू ए सेपरेट सॉकेट, ठीक है. इनिशियली जब कनेक्शन आप करेंगे तो आप एक ही डेस्टिनेशन पोर्ट पे जाएंगे, which is going to be a well known port, because देखिए अगर आपको पोर्ट पता ही नहीं है कि जब आपने यहाँ पे इस IP let's say DNS के थ्रू you will be able to identify what is the IP address of the destination, ठीक है. लेकिन डेस्टिनेशन पे पहुंच के उस घर पहुंच गए आप, अब आपने you have to communicate with a particular process running over there. Let's say it's a web server. So web server के साथ कम्युनिकेट करने के लिए you need to know the port number जिस पे आपने कम्युनिकेट करना है. चूंकि सारे क्लाइंट्स ने इसी वेब सर्वर के साथ कम्युनिकेट करना है, तो जो वेब सर्वर है उसका जो पोर्ट नंबर है that is known as a well-known port number. It's announced, predefined, announced, it's fixed. Port number let's say 80. तो जब भी आप किसी वेब सर्वर से कांटेक्ट करते हैं तो you contact at port number 80, ठीक है. वो क्या करता है कि अच्छा वो फिर एक सेपरेट कनेक्शन सेटअप करता है जिसमें इट्स गोइंग टू यूज दीज 4 थिंग्स, द सोर्स आईपी एंड द सोर्स पोर्ट नंबर. नोटिस कि हर एक क्लाइंट का पोर्ट नंबर अलग अलग होगा, सोर्स पोर्ट, ठीक है. एंड जो डेस्टिनेशन एड्रेस है, ठीक है, दैट्स गोइंग टू बी द सेम कॉमन एड्रेस ऑफ द वेब सर्वर, जो कि आईपी एड्रेस है उसका है, एंड उसका जो पोर्ट नंबर है दैट्स अ वेल नोन पोर्ट नंबर व्हिच इज पोर्ट नंबर 80, ठीक है. इसी तरह से ये जो वेब क्लाइंट है ये जब कम्युनिकेट करता है इसका सोर्स पोर्ट नंबर डिफरेंट है, आईपी ऑफ कोर्स डिफरेंट होगा, लेकिन डेस्टिनेशन आईपी इसी वेब सर्वर का होगा एंड डेस्टिनेशन पे पोर्ट नंबर इज स्टिल 80। ठीक है, ये भी डेस्टिनेशन 80 है, ये भी डेस्टिनेशन 80 है, दोनों क्लाइंट्स इसी एक वेब सर्वर के साथ कम्युनिकेट कर रहे हैं। ठीक है, लेकिन उस वेब सर्वर का जो पर्टिकुलर थ्रेड, ठीक है, इस क्लाइंट को हैंडल कर रहा है और इस क्लाइंट को हैंडल कर रहा है, ये वो पर्टिकुलर सब प्रोसेस जो है वो सेपरेट होगा। बिकॉज हो सकता है कि इस क्लाइंट ने कोई और चीज रिक्वेस्ट की है फ्रॉम द सर्वर, इस क्लाइंट ने कोई और चीज रिक्वेस्ट की है, तो आपने सेपरेटली ट्रैक रखना है कि अच्छा इसको मैंने क्या भेज दिया और क्या पेंडिंग है, इस एक सेपरेट कनेक्शन के थ्रू ट्रैक रखना है कि क्या भेज दिया और क्या पेंडिंग है। It's a different connection. Although the port number of the destination is 80 in both cases, ठीक है, this server is going to set up a new sub process to handle this new connection to this new client. ठीक है, जिस तरह से आप एक ही एंड सिस्टम पे मल्टीपल ब्राउजर विंडोज भी खोल सकते हैं। ठीक है, अब उनको हैंडल करने के लिए भी आपको एक अलग आइडेंटिफायर चाहिए होगा। ठीक है, वरना एक विंडो में you don't want कि कोई दूसरी चीजें आना शुरू हो जाए, right? So you have set up 2 windows, so you need to have some identifier which is going to separate them out.
Right, sir. Thank you.
Any other questions? Okay, so this is a threaded server P4. It's a it's a web server, and basically कर ये रहा है कि it's setting up a new thread or setting up a new sub process for each one of these separate connections. Now, connectionless transport, we'll quickly cover this. UDP, this is no frills or bare bones. Best effort, and best effort we talked about, it means no guarantees or is totally unreliable. And it's connectionless, which means that no handshakes take place between the sender and receiver, which means before you transmit data, there is no exchange of packets, no exchange of segments, which set up the connection. Setting up a connection simply means storing some state. कि ये connection के बारे में चंद जरूरी parameters, identifiers आप पहले से रख लेते हैं. That is setting up a connection. So UDP is used for streaming media, where applications are loss tolerant but rate sensitive. So DNS, SNMP, जो कि आपके पास एक प्रोटोकॉल है for the management of the network, and जहाँ पे आपके पास reliable transfer चाहिए आपको, so then you have to add that reliability in the application layer. ठीक है? So notice कि I can still use UDP and build the reliability, the tracking, the numbering in the application layer and achieve the same results. ठीक है? एक ये कि application layer uses the service of the transport layer, and the transport layer provides you that reliability that is using TCP. I can still use at the transport layer an unreliable protocol such as UDP, and then I will have to build that reliability into my application layer, which is an overhead, which is something I don't want to do. अगर मुझे reliable service मिल रही है, so rather than building that in the application layer, I will use a reliable transport layer protocol such as TCP. But if I want to build my own reliability, ठीक है, I want to use a different flow control algorithm, I could do that, building that on top of UDP. ठीक है, ये बात समझ गए? Any questions here? Is this clear? So UDP क्या करता है? It provides for the source port number, destination port number, and इसके अलावा 2 more things. The length of the segment, ठीक है जी? So this is the length of the application data payload plus this header, as well as a checksum, which is simply an internet checksum kind of a thing. Checksum का idea है आप लोगों को? Checksum. So you could do something as simple as adding up, assuming that ये सारे 16-bit numbers हैं, adding up all 16 bits के, so you break up your entire segment into 16-bit chunks and add them all up, and जो आपके पास result आता है उसका let's say आप ones complement ले ले. So a ones complement checksum is going to be breaking up because notice कि ये checksum 16 bits का है, इसकी length 16 bits है. So this checksum corresponds to taking all 16 bits of the header as well as 16 bits के आपके पास application data का जो payload है, adding them up as 16-bit numbers and then taking a ones complement of that. Now, what this does is that when I receive a packet, I can perform a checksum again. And if that checksum matches with this value stored in the header, that means कि सारे के सारे bits जो है ना वो सही पहुंचे हैं, ठीक है? या ये कि इस किस्म के error हुआ है कि तब भी I cannot detect the error. Now, the probability of that happening, an error such that the checksum remains the same and is correct, is very, very small, provided that your probability of bit error is very small. ठीक है? Notice के अगर checksum आपका सही है, so that does not necessarily give you with probability 1 कि आपके पास packet सही पहुंचा है, because you could have errors in such a way that your checksum still remains intact. Okay? But the probability of that event happening is very, very small. Right? Is this clear कि checksum क्या कर रहा है? Checksum is simply checking कि ये जो UDP packet पहुंचा है, ये ठीक है या corrupt हो गया. That's it. Okay? So the goal of the checksum is to detect errors because bits can get flipped. A 0 can get converted to a 1 and vice versa. Okay. So one simple thing that you can do is you can add up the entire contents of the segment, thinking of it as it's a sequence of 16-bit integers. You add them all up, take the ones complement, and your result data, you place that in the header, and that is the checksum. Receiving side pay, you compute the checksum again independently. And if the checksum equals the checksum in the field, there is no error detected, almost. And if it is yes, then you could have errors. Okay? Lekin errors ko aap correct nahi kar sakte. All you know is this datagram that you received is corrupted. Okay? Here's an example. Suppose you had just two 16-bit numbers, you add them up, okay? And you're adding them up in binary. Ye jo aapke paas, you've got the carry at the end, isko aap least significant bit pe add kar dete hain, and you get the sum. Ab is sum ka aapne ones complement liya, you get here this sequence over here. This 16-bit sequence over here is the checksum. So if you do this for adding up all the contents of the entire header and the payload, you can work out the checksum for that. So iske different checksum ke methods and we will cover them in more detail subsequently. But this is just to give you an idea ke checksum karta kya. Right, so any questions so far? I think I need to sit and stand, take a break. Right, so Ji, bataएं. We'll just take a couple of minutes break. Any questions? Are you there? My daughter tells me the best thing about Zoom is that you switch off the video and you switch off and you mute the microphone and आराम से ठंड रख के बैठ जाते हैं. There's nothing more. That's the best feature of Zoom. Is that the case? Yeah. So we have a question here. So doesn't UDP also use IP for sending packets? Yes, it does. So how does it rely on the port numbers only? Okay, port numbers, so aapke paas IP is to get the datagram forwarded to the right end system. So once you get to the end system, then you're using the port number to get to the right process within the end system. ठीक है? So ऐसा नहीं है कि सिर्फ पोर्ट नंबर से आपका काम चलेगा. You're still relying on IP. IP is delivering your datagram to the right end system, and there, in order to multiplex and get to the right process running on your end system, you will rely on the port number. ठीक है? Any other questions? जी. No questions? Okay. Okay, so we'll talk about these principles of reliable data transfer. Ab yahan pe what we'll do is step by step we'll define this, and we will think about what are the problems that we can encounter, and un problems ko aap kaise overcome kar sakte hain by building in systems in the end systems, ठीक है, which will allow you to recover from those particular problems. So पहली चीज ये है कि this is sort of providing reliable transport end to end over a network is a very important topic in internet research, ठीक है, and is listed as one of the top 10 important networking topics. So यहाँ पे if you think about it, पहले आप ये समझ लें कि you've got the application layer and the transport layer between the sending process and the receiving process. So the first step is to view this as a reliable channel, and उसमें आपके पास what you actually have is that you have sending process which has some data to transmit, ठीक है? The application layer is going to pass that data to its local transport layer, ठीक है? And then over the cloud, वो अपने transport layer application layer को भेजेगा, hop by hop वो चीज recipient की transport layer तक पहुंच जाएगी, and then it's going to pass that data up to the application layer process at the receiver. So the first thing that we can assume is that we have a reliable channel between these two transport layers. We have a reliable logical channel between the transport layers, ठीक है? And अगर ये channel ऐसे है कि it's completely reliable, there is no data loss over here, there is no bit errors over here, there are no kinds of other problems over here. So then what you have is, ठीक है, you're going to have a reliable service between these two end processes. Now, in reality, आपकी जो service है, that is actually implemented over an unreliable channel, ठीक है? तो उस केस में क्या होगा कि आपके पास ऊपर से तो आपके पास your sending process is going to send data down to your transport layer, ठीक है? And your transport layer is then going to make a packet out of this data and send this over an unreliable data transport channel, unreliable channel के ऊपर. वो फिर आपके पास receive होगा on the other side, packet, and then you are then somehow going to be providing a reliable data transfer service to the application layer above. So all of that sequencing, building in, tracking कि कौन सा segment पहुंच गया, कौन सा नहीं पहुंचा, कौन सा retransmit करना है, all of that will have to be built in as part of this service. ठीक है? Now notice the notation that we're using. We're using this RDT as Reliable Data Transport Protocol. ठीक है? RDT. Underscore send means that this is the method or the function used to send this data down. ठीक है? अब ये over the unreliable channel, you're going to transmit this data through an unreliable data transport send. The application layer will call the reliable data transport send. ठीक है? The service provided by this is reliable. So application layer is relying on the transport layer, and that's why we're calling this reliable data transport protocol. ठीक है? ये जो transport layer है, it is using the best effort service provided by IP over an unreliable channel. So the send that it's doing is, of course, on an unreliable data transport send. ठीक है? On the receiving side, जब आपको एक packet receive होगा, ठीक है, we're simply calling this a receive. And overall, because this is reliable service, we're calling this a reliable data transport receive on this unreliable channel. The transport layer protocol will then keep track of कौन सा packet मिला, नहीं मिला, दोबारा भेजना, acknowledgement भेजनी है, नहीं भेजनी. It'll do some extra processing over here and then deliver this data reliably to the application layer above. ठीक है? Now the characteristics of this unreliable channel, ये unreliable channel क्या कर सकती है? अगर तो सिर्फ data को lose करेगी, उसमें you have to build in something for taking care of data loss. अगर data loss के अलावा data corrupt भी हो सकता है, तो उसके लिए you have to build something over here for that. ठीक है? अगर वो out of order भी आ सकते हैं, when they were forwarded hop by hop, you'll have to build in something for that. ठीक है? If you are to guarantee a certain data rate or certain other guarantees, you have to build in something for that. So congestion control भी आपने करनी है, flow control भी आप कर सकते हैं, tracking भी आप कर सकते हैं, उसको efficient करने के लिए और techniques हैं, and we'll cover these one by one. Right. So is this notation clear? Send side Kuper and receive side Kuper, how are we actually labeling this? Any questions over here? Now, reliable data transfer protocol we will use these finite state machines, FSMs, to specify exactly what is taking place. So we have circles, and within circles, we've got the states. And then you've got, let's say, a transition from state 1 to state 2. Now, transitions are shown by arrows, and the events that cause the transition are written above the line, and your actions are ले रहे हैं on the state transition, we're going to write them below the line. So that's the notation. States represented by circles, transition between states by arrows, and corresponding to each arrow, we are writing down events causing the state transition above the line and actions taken on the state transition below the line. Okay. Now, सबसे पहले आपके पास we will talk about RDT, Reliable Data Transport 1.0, which is reliable transfer over a reliable channel. So इसमें the underlying assumptions are that the underlying channel is perfectly reliable, there are no bit errors, and there is no loss of packets. So if there's no bit errors and no loss of packets, तो जो चीज़ आप भेजेंगे वो वैसी की वैसी receive होगी, ना वो corrupt होगी, ना वो गुम होगी, ठीक है? So we have two separate finite state machines, one for the sender and one for the receiver. And ये जो dotted line है, ये आप दिखा रहे हैं कि अच्छा ऊपर से, ठीक है? We're waiting for a call from above. So when the application process has data to transmit, ठीक है? It's going to send us that data, and we will be waiting for that data. As soon as we receive that data, okay, we will make a packet out of that, okay, and we will transmit or send that packet over the channel. Okay. So notice that we are transitioning from the same state back to the state over here. We're waiting for a call from above. When we receive that data, आपने क्या किया कि आपने पैकेट को बना के भेज दिया और फिर दोबारा इंतजार करने लगे for more data to arrive from above. When more data arrives, we're going to simply create a packet of that data and transmit that data. Okay. And notice we're transitioning from the same state back to the same state. Okay. So when we send that data, that's the event that is taking place for us to transition but we're transitioning back to the same state. We're not transitioning to a new state. So we're sort of looping back to the same state. And these are the actions taken on receiving that data from above. And they are making the packet and transmitting the packet. Sender side, ये है. Receiver side पे we're waiting for data from below. जब data packet आपको receive हो गया, आपने क्या किया कि you've extracted the data from the packet and delivered the data to the layer above. ठीक है, so all you're doing is receiving a packet, stripping the header off, and जो भी payload है उसका है, you're transporting that payload to the layer above. ठीक है, so in this finite state machine, once again you're waiting for a call from below. जब आपके पास ये action हुआ कि you received a packet, you're going to strip the packet off its header and send the data up, deliver the data up to the layer above, to the application process. And this is transitioning you back to the same state again. Now you're waiting for the next packet to arrive from below. Okay? So this is one-way communication between a sender and a receiver. Sender is receiving data from the application process above. As soon as it receives data, it makes a packet and sends it, and then waits for more data to be received from the application layer above. Receiver receives that data, strips the header, and sends the payload to the layer above, and waits for more data to be received from the network layer below. Any questions here? This is 1.0. Now, the first thing that we're going to do is we're going to introduce the possibility that आपके पास जो packet आप भेज रहे हैं, जो segment आप भेज रहे हैं, it could contain errors. So it can corrupt the data. So if the data can be corrupted, the first question is, how do you know that the data is corrupt? You will have to introduce some checksum to detect bit errors. तो आपको transmission side पे checksum डालना है, and receiving side पे checksum अलग से दोबारा से calculate करना है, and header के checksum से compare करना है. अगर दोनों बराबर हैं, तो packet आपको ठीक मिला है. अगर उसमें error है, so you know straight away that this packet is corrupted. ठीक है? Now, if it is corrupted, so what do you do then? So for this, we will think about what humans do when they recover from errors during a conversation. अगर एक बंदा बात कर रहा है, ठीक है? So how does he know कि whatever he's saying is being understood? He would need to have some feedback, some acknowledgement from the recipient. कि अगर packet ठीक पहुंच गया है, तो receiver should say, acknowledge कि हाँ ठीक पहुंच गया है, बात समझ आ रही है. अगर नहीं समझ आ रही, so the receiver should say कि please, the receiver should give some feedback, negative acknowledgement कि बात समझ नहीं आ रही. So you would say something, and the receiver would say, You'd say something, the listener would say, huh? You'd say something, the listener would say, huh? So when the listener says, huh, or says, what did you say? Dobara kahe, repeat, theek hai? Then the transmitter knows that there's a problem, and the transmitter will then repeat what is being said. theek hai? So at the moment, we're only considering the fact that jo aap packet bhej rahe hain, wo corrupt ho sakta hai. Agar aapne jo acknowledgement bheji hai, वो corrupt हो जाए, या जो आपने negative acknowledgement भेजी है वो corrupt हो जाए, so that's a different scenario, that is more complexity, उस पे बाद में आएंगे. ठीक है? So that's the first assumption, that whatever you're transmitting can get corrupted. तो corruption को check करने के लिए you need to have a checksum. ठीक है? And then you need to have, to recover from errors, you need to have acknowledgements in which the receiver explicitly tells the sender that the packet received is okay, and agar gadbad hai, so it's going to provide negative acknowledgements, which it explicitly tells you that there has been an error. Okay? So you will need some mechanism for error detection, जो कि पहले नहीं था 1.0 में, and then you need special messages, feedback control messages. एक message ठीक पहुंच गया, which is acknowledgement, and अगर error detect हो गया, you'd have to send a NAC back, a negative acknowledgement back, from the receiver to the sender, telling it कि ये पैकेट ठीक नहीं पहुंचा, आप इसको दोबारा से भेजें, retransmit करें. ठीक है जी? So any questions so far? Now, if you look at the finite state machine here, आपके पास you're waiting for call from above. जब आपके पास you have data to send from, you're going to create your packet. So now, not only are you going to simply create your packet, you're also going to create a checksum along with your packet. And then you're going to send the packet. Now, after this sending the packet, जब reliable था आपके पास, so you would then wait for the next packet because you were sure that what you transmitted is going to get through without any errors. यहाँ पे you are not sure. So you're going to wait. So you're going to transition from here, from this state, waiting for a call from above. You're going to wait for an ACK or an ACK to be sent, to be received. ठीक है? Wait for an ACK or an ACK to be received from the receiver. जब तक ये आपको ACK receive नहीं होता, ठीक है? तो उस वक्त तक आप यहाँ पे you will stay here. So once you receive a packet and that packet is an ACK, ठीक है? तो फिर आप क्या करेंगे कि you know कि रिसीवर को ठीक रिसीव नहीं हुआ, आप उसी पैकेट को दोबारा से भेजेंगे. And you will wait again. So until you receive an ACK, you will keep on receiving each NAC, you will keep on transmitting the same packet again. ठीक है? If you receive a packet and that is an ACK, then of course you will do nothing but simply transition from this state to this state over here, which is waiting for a call from above. Now this protocol is called a stop and wait protocol because आपने एक packet भेजा and now you are waiting for receiving an ACK or an ACK, and जब तक आपको ACK नहीं मिलता, you cannot transmit the next particular segment to the receiver. So you send one, you're waiting for an ACK. If you get an ACK, you're going to retransmit that packet. ठीक है जी? जी, question ही आसिफ.
सर जिस तरह भी आपने कहा कि जब एक पैकेट हम सेंड कर देंगे तो फिर हम ACK या NAC का वेट करेंगे, जब तक हमें ACK नहीं आ जाती तो तब तक हम दूसरा पैकेट सेंड नहीं करेंगे. तो इट मींस कि तो ये बाय डिफॉल्ट इन ऑर्डर डिलीवरी ही है, तो हमें नंबर या आइडेंटिफायर की जरूरत क्यों पड़ेगी इन ऑर्डर के लिए?
तो इसमें आइडेंटिफायर नंबर नहीं है. देखिए आपने पैकेट बनाया और उसके साथ चेकसम लगा दिया एंड आपने पैकेट को भेज दिया. So there is no numbering over here. जब तक आपको ACK नहीं मिला, आपने उसी को रिट्रांसमिट किया. अगर NAC मिला तो रिट्रांसमिट किया, अगर ACK मिला तो आप इंतजार करेंगे for the next call from the application layer above to be sent data. So there is no numbering of packets, but you are waiting for an ACK or a NAC. ठीक है? लेकिन नोटिस कि assumptions क्या है? assumption है कि पैकेट करप्ट हो सकता है. यहाँ पे ये assumption नहीं है कि पैकेट गुम हो सकता है. यहाँ पे ये assumption नहीं है कि ACK करप्ट हो सकती है या NAC करप्ट हो सकती है या ACK और NAC मिसिंग हो सकती है. ये assumptions अभी नहीं. ठीक है? रिसीविंग साइड पे you are waiting for a call from below. अगर आपको पैकेट रिसीव हुआ एंड वो करप्ट है तो आप NAC वापस सेंड कर देंगे. अगर पैकेट रिसीव हुआ एंड दैट इज नॉट करप्ट, चेकसम उसका ठीक है, तो आपने उसका डेटा निकाल के हायर लेयर को दे देना है और वापस ACK भेज देना है. ओके? एनी क्वेश्चंस हियर? So यहाँ पे you wait for the call from above and यहाँ पे the other side, receiving side is waiting for data. जब ऊपर से आपके पास data आ गया to transmit, आपने data भेज दिया, you've created the data packet by adding a checksum, you send that packet. On the receiving side, आपको packet मिला and suppose that was not corrupt. So what you do is you're going to extract that data, deliver that data to the application layer above and send an ACK back on receiving the ACK back, okay, you're going to move from this wait state back to the waiting for data from above state. So आपका stop and wait complete हो गया cycle, and now you're waiting for the next one. अगर आपने पैकेट डेटा ऊपर से आया, पैकेट भेजा आपने रिसीविंग साइड पे, वो पैकेट करप्ट था, यू गोइंग टू सेंड अ NAC बैक. नोटिस NAC लाजमी पहुंचेगा वापस. as soon as NAC पहुंचा तो आपने दोबारा उसी डेटा को रीट्रांसमिट किया. इस दफा लेट्स सपोज कि वो डेटा सही पहुंच गया, इट्स नॉट करप्टेड, यू गोइंग टू सेंड द ACK बैक, and the ACK is going to then, on receiving the ACK, you're then going to move to the wait for a call from above state. Okay? Now, this has a fatal flaw, and that flaw, of course, is what happens if the ACK or NAP is corrupted. Okay? The sender doesn't know what happened at the receiver. Think of them, these could be thousands of miles apart. There could be hundreds of hops between the two systems. Okay? And if your NAC or ACK got corrupted across those multiple hops, then the sender wouldn't know कि क्या मसला क्या हो. ठीक है? So we'll get to more of these details, and basically this is an example of what you call a stop and wait protocol. ठीक है जी? Okay, so any questions before we end? Any questions? Okay, so just an announcement again. Friday we won't have a class. We'll have a class on Saturday, inshallah. And there was some request that जो है वो इस दफा संडे को एग्जाम ना लिया जाए. वो फिर देख लेते हैं. I'll discuss it with Zartash. या इसको नहीं लेंगे फिर या अगले को नहीं लेंगे. However you want to have it done, we can do it like that. If you have midterms this week, then it makes sense not to have one on Sunday. If you have them next week, we will discuss that. जैसे भी आपको आसानी है. Okay. Any questions? Any questions? Okay, so thank you very much. Thank you. Khuda Hafiz.